In this video, we're going to cover section 3.3, which is the section on differentiation rules. So let me just make a note here that on the first test, we will not be allowed to use these rules to take derivatives. On the first test, we'll use the definition. But then on the second test will be sort of the rules test. Okay, so I just want to make sure that nobody loses points on the first test. Okay, so first of all, let's look at the theorem here, and we've got two functions, f and g. These are real valued functions, and then we're also going to have two constants, the c and the little r. Those are just constant numbers. And so the first rule is pretty basic. It's the constant rule. And so it just tells us that the derivative of any constant is 0. And I think I'll allude to this later on, but we just have to remember the difference between the limit of a constant and the derivative of a constant. So remember that the limit of a constant is that constant, but the derivative of a constant is 0. All right, and then we're going to look at the power rule. And the power rule, as you can see, is, how do we take the derivative of x to a power? Well, as it turns out, what we do is we bring down the exponent in front. That's where we get this. And then copy over the x. And then the new exponent is just the old exponent minus 1. So here, to get the new exponent, we subtract 1. So bring down the exponent, copy over the x, and then the new exponent is you subtract 1 to get that. And we'll look at several examples to exercise these rules. All right, so rule 3 is the constant multiple rule, and this one's very useful. So if we're taking the derivative of some constant c times a function f, then what the constant multiple rule says is that we can bring that constant out in front. So this constant can just come out in front, and so it's just the constant times the derivative of what remains. And so, like I said, that's pretty useful. That noise was my phone. Sorry about that. Okay, the sum rule is just what you would expect. If we take the derivative of a sum, that's equal to the sum of the derivatives. And then lastly, we'll look at the product rule and the quotient rule. And I won't say too much about these right now. When we get to the example where we need to use these rules, then we'll come back and I'll kind of give you a mnemonic device to help you remember what these two rules are. So let's get to looking at the exercises and see if we can just use the first 4 rules for now, and then we'll come back to 5 and 6 in a moment. Okay, so for example 1, this is just iterating or reiterating what I said before. So the limit of a constant, so for part A it says evaluate. So for part A we're taking the limit of the constant 3 as x approaches pi, although it doesn't really matter. If you're taking the limit of a constant, it doesn't really matter what x is approaching. The limit of the constant is the constant. But the derivative, so for part B, the derivative of the constant is 0. So that's that example. And this note here is just what I just said. Okay, so that's the constant rule. All right, so if you will recall, in the previous section when we learned about the definition of the derivative, we showed using the limit definition that if f of x is x to the 3rd power, then its derivative is 3x squared. Now, if you're thinking about the power rule, you'll see why that's true. But we did compute this derivative before. So then, if that's the case, then let's define g of x to be the constant pi times f of x. And so if that's the case, then the question is, what is g prime of x? Well, here we're just going to use that constant multiple rule. Whoops, sorry about that. I don't know what. Okay, here we go. Now we're back. This is where we are. Okay, so g prime of x, that's here. That's the derivative with respect to x of g of x. And that's equal to, well, g of x is, by definition, pi times f of x. We know that. Let me get rid of that part. Okay. So the derivative with respect to x of pi times f of x. So here's where we're going to move that constant out in front. So we can take this pi and put it in front. And so that's equal to pi times the derivative of f of x, which is, written a different way. That's pi times f prime of x. And so now we just recall that f prime of x, we know what that is. That's 3x squared. So then we can write that g prime of x is equal to pi times f prime, which is the 3x squared. So g prime of x is 3 pi times x squared. Okay, so there's an example of the constant multiple rule. Now let's look at example 3 and use the power rule to evaluate. And I didn't write the answers here, so we'll just do it now. So remember that when we use the power rule, the first step is to bring down the exponent. So here we're taking, for part A, we're taking the derivative of x to the third power. So we're going to bring down the exponent in front, copy over the x, and then we're going to subtract 1 from the old exponent. So the new exponent is 3 minus 1, which is 2. And that's it. All right, so for part B, we're taking the derivative of x to the power pi. So we bring down the exponent, so bring down the pi, and then times x to the new power is, the old power minus 1. Okay, so the pi times x to the pi minus 1. And that's part B. All right, for part C, we're going to have to do a little bit of manipulation to this function that we're taking the derivative of before we actually take the derivative. So let's write that as the derivative of, and so, we're not taking the derivative yet, so we're just going to re-express this function, this 1 over x to the fourth. We're going to write that as x to the negative 4 power. And so that puts it in a form where we can readily use the power rule. So now we're going to take the derivative. And so remember, if we take the derivative of x to a power, we bring down the power, bring down the exponent. So the exponent is negative 4 times x. And then the new exponent, so we just subtract 1. So negative 4 minus 1 is negative 5. And that is our derivative. Okay. And then similar to part C, we're going to have to do a little work on this expression before we can actually take its derivative. So for part D, our first step is to write this still as the derivative. So we're not taking the derivative yet. We're just going to write this as x raised to an exponent. And let's see, it's going to be, it's power, so 2 plus pi divided by root. Remember, it's power divided by root, and so the root is the second root. We're taking the square root. So that's correct. And then we can take the derivative. So let's see, we're going to bring down that power. As complicated as it is, we're going to bring it down. And then times x to a new power, and to get the new power, we're just going to subtract 1. So it's 2 plus pi over 2, and then subtract 1. Well, I'm going to write that as 2 over 2. And I think it's kind of obvious why I did that, because that way I'll have common denominators, right? Because we all know that 2 over 2 is just 1. So I'm still just subtracting 1. So if we simplify this a bit, we have 2 plus pi all over 2 times x to the power, well, it would just be pi over 2. Yeah, just pi over 2 would be the new power. Okay, so there's the derivative of that one. Okay, so let's forge ahead. So at this point, we're going to kind of mix all this stuff together. And I will tell you that on the test, I'm not going to say use this rule or use that rule. I'm just going to give you a function, and I'm going to ask you for the derivative. So you just have to, know what these rules are and be able to apply them. Okay, so let's work on this first one. So maybe I should have put the equal down here, but oh well. All right, so, well, instead of writing out each rule in great detail, let's just kind of do it the way we would do it on the test. So let's focus on the pi times x to the third part. Well, the pi is just a constant, so I'm just going to pull it out front and forget about it for a second. So now we need to take the derivative of the x to the third part, and that's going to require the power rule. So we bring down the 3, copy over the x, and then subtract 1, so it's 3x squared, okay, plus, okay, and then for the second term here, the square root of 2, that's a constant. I'm just going to put it out in the front and just sort of forget about it for a little while. And then we need to take the derivative of x squared. Well, x squared, I'm going to use the power rule. We bring down the 2, copy over the x, and subtract 1 from the exponent, so it's going to be 1. 2 minus 1 is 1, obviously. And minus, well, the derivative of 3 times x is just 3. Okay, if you want to see why, well, we could use the power rule to figure that out. So let's continue, treat this the way we did, the previous terms. Pull out the 3. And then if we use the power rule on this one, we have x to the first power. So we would bring down the power, copy over the x, and then if we subtract 1, then it's x to the power 0. And of course, x to the power 0 is just 1. Okay, and then plus. And lastly, this e is just an irrational number. I believe it's at the beginning of Calculus 2, where you learn all about the transcendental functions and the exponentials and the logarithms, natural logarithms, and stuff like that. And so that's where this number e sort of comes from. But just realize e is just a constant. It's just a constant number. And so we know that the derivative of a constant is 0. So that's just 0 there. Okay, so if we clean this up a bit, we have 3 pi x squared plus 2 square root of 2x minus 3. And there's our derivative. Okay, let's look at part B. So here, just to kind of mix things up, instead of using, f and y and x, we're going to use r as a function of theta. So we're looking at just using different variables. So here we're given r as a function of theta, and we're asked to find r prime of theta, or the derivative of r with respect to theta. And just as an aside, if you're wondering what the other notation for that would be, well, it would be dr d theta would be another way to write that. Okay, but we'll just stick with the prime notation since that's how it was asked. All right, so for this problem, we need to work on the expression of r just a little bit because we're going to need to use the power rule. So the first step is to just rewrite r and sort of bring all these denominators up to the top. And so that would be 12 times theta to the -1 minus 4 times theta to the -3 plus, let's see, theta to the -4. Yeah, okay. And so in this form, we can readily use the power rule. Okay, so then r prime of theta is, well, okay, just write down the constant 12. And then now it's theta to the -1, so we're going to bring down the -1, copy over the theta, and then subtract 1 will give us -2. And then it's minus, and then the number 4 times. And then for the theta to the -3 part, we're going to bring down the -3, and then times theta to the, let's say, subtract 1, that'd be -4. And then a plus, and then here we've got theta to the -4, so we're going to bring down the -4 times theta to the -5. All right, so then let's just clean this up a little bit. So it's -12 theta to the -2 plus 12 theta to the -4 minus 4 theta to the -5. And if you wish, you can continue and you can move those thetas back down to the denominators. But we'll just leave it there. That's fine. Okay, so now we get to example 5, which is the product rule. I'll tell you what, we'll do a new video and we'll start from there and we'll finish this, this section in the next video.